Hello and welcome back once again to the show. My name's Relevant. This is Do All the Things, and on today's episode, Trainbox, the final frontier, or at least the final stage. We're going to put together the output module, and then once it's finished and fitted, this is pretty much done. So, if you've been following this comedy, stay tuned. We're going to wrap this up. So having made some last minute circuit revisions, I had to shuffle some stuff around here because I think I flashed this in the last video showing you basically what was going on. I had this heatsink, absolutely frickin' overkill for the application, and the fitment in real life wasn't as good as what I was expecting on paper. I actually salvaged this thing out of a television power supply, or at least a broken television power supply, and I just have to do some custom fitting. It's just aluminum. You know, I got some little tabs here for mounting it. We got to cut her down to the right size and then get those tabs on there. And you're gonna see it's plain aluminum. It's got the things mounted right onto it. Fortunately, the IXDD609, they have a common ground plane. The middle pin is the ground pin, the negative, and these things both have a jumper negative, so I haven't got to worry about that. They can attach Raw Dog to the same heatsink because they don't have to worry about isolation. So that's perfect. This other guy, it has isolation features on it, so we're gonna save that for a project that needs more heat sinking and isolation. This thing I think I'm gonna get to fit better anyway, but I gotta chop it up. So that's where we're gonna start here today, which hopefully we can get some straight lines. We'll give ourselves a fighting chance by like chewing up the cuts we need to make. Now I guess I just get on a hacksaw. Good thing it's aluminum, right? Right here. Yeah, if only this vise wasn't crap for this. We'll be through it in no time. Yeah, the great thing is we got another heatsink out of the deal I could use for another project. And the bad thing is I got flakes all over me. It's funny how you get used to glitter all over your crotch area from raining shavings. That's funny. It's been a while since I've manually cut something like that. Yeah, a little bit of good old-fashioned manual fabrication. Don't do that too often in electronics. Alright, so chances are this is roughly the right width we need now. Now I just have to get those mounting tangs in place, and in order to do that, I need them to go in more. Which means I gotta cut off a bit of what's going on here. Just a little bit though, just a little bit. About that much. And then cut in. Oh, this is a bit surgical. Bit too surgical for a tool of this nature. It's happening though. It's happening. Now we should be able to get those mounting tangs into place, or whatever you want to call them. I almost feel like I put that one a bit too much in. So we have to confirm positioning here. Means I gotta count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, this is lettered, so let's letter it. A, B, C, D, E, F, G, H, I, J. So these need to be over position J. And the tangs, which slip in the side here, would be in F and G. So we need to enlarge in F and G. We have to enlarge in a bunch of holes. Like the hardest part of this process is the fitting. We're not F and G, F and H. I don't know if this bit's big enough to get the hole size we need though. Might be if we didn't have goops of solder on here. No, I think it has to go a bit bigger, but also we gotta get the solder off of it. There is also option 2, make these smaller. Okay, I think that'll work. So let's enlarge in the other 2 holes opposite and fit on those too. You know, you get one of these chuck adapters where it goes into like your impact drill, and you just use it as a spinning top when you just need to quickly fix on a couple holes. Now let's shape on the other one. Okay, so these things have to get refitted back into the heatsink. I hammered them out, so I should just be able to tap them back in with a punch just like this. Oh, assuming this doesn't move more. I gotta be careful with my spacing. I gotta make sure all this lines up, so I'm not going all the way just yet. We're pretty much bang on first try here. Problem is we gotta mind that our components lined up too. Oh, yeah. Wow. I just used the force with that one, but I tell you what. Okay, good. I just have to get it through its holes. This thing's practically swaging into place. Well, isn't that cute now? Yeah, that'll do. That'll do. Now, the mounting holes, which I probably should have managed first. So screw here, screw here. They're gonna be for 632s. That would be 3 and 1 over right there and right there respectively. And that has to line up with the mounting holes on my terminal strip. That is gonna be holding on to my wires. So that should be fine. Now I need holes for these terminals that aren't necessarily getting glued into place. That's gonna be right here and right here. And they're between holes, so that's gonna be fun. Oh, wow. When is a drill a milling machine? When it walks, but then walks back. So now the idea here is we have 1/4 inch spacers. What size screws are we gonna use? Looks like 1 inch will do, just. So the chassis is gonna go in between. These guys snug up roughly. Come on, bud. And then that is gonna be on the outside, facing in, doing something like that. And then once we get some kep nuts on there, hopefully they clear. Yeah. That's gonna be what's mounting this board. Nice. I just figured out this heatsink assembly like in the last minute before I clicked record, so that's fun times. Except it's taking up a bit more room. We're gonna have to get creative with like the placement of this capacitor. We'll figure it out. Okay, so on the box in question, this is gonna mount under here. You see, right in here like this. Yeah, which puts our screw holes roughly right here. I do declare. Yes. Pencil is harder to wash out than you think, so let's be light with it. But I'm gonna pop some alignment here. All right, so now we can plop this down right like that. We could actually probably go in a little bit. How much room do we have here? Okay, we're gonna put it one of these away. So right here, need 4 holes. One here, one here, one here, one here. Let's see if we can pilot it without the punch with our spinning top. That's the 2 main screw holes. Now for the pass-throughs of the terminals, I'm gonna make them bigger. Need a little bit more relief in that. So they're just gonna be passing through a metal hole with no real insulation. I guess we could probably stick a bit of heat shrink around them. Either way, as long as we make the hole big enough, we don't have to worry about it. So we want literally the biggest hole that we can make that would get covered up. 1/4 inch even. You're not gonna see a 1/4 inch hole under there. We should actually confirm our alignment here. Oh yeah, that's pretty good. This one needs to move over just a little bit. Let's see if I can right beside it more still. Okay, if I can get it right in between these two, that'll be good. All right, 1/4 inch hole, wish me luck. I feel like that one walked a bit. Of course it did. All right, we done turning this thing into Swiss cheese yet. I need to do a little chamfer and deburr here. Be able to get it from the other side. This should just slot right in there now. Put our standoffs into place. Ha! So that's what our output terminal is gonna look like. Looks pretty straight. There's what it's like from inside. Right? So we got the holes it pokes through. It looks like there might be metal, but it's kind of recessed into the plastic, so it can't make contact. But the idea now is our board assembly would sit right on there, get screwed down, and ta-da! Fitting complete. Tricky part is getting in there to get wires on those terminals. Because I don't plan on soldering them to the board. I plan on having some wires that come up and wrap around. Loops. I'm gonna have to make loops. But nevertheless, I could start perf boarding this now. I'm not gonna film it this time because it's a lot of work and a lot of time. You can watch the last video if you want to see perf boarding tips and tricks and secrets. This guy, I'm gonna hammer at it. Be right back. And here it is. Look at it. Take a good look at it. On the back end, we've got these loops that will be soldered to the terminals that poke through. Heatsink soldered into place. There's our 2 drivers, our connector for our control input, our power input, 1 resistor, and 3 capacitors. All power traces are doubled up. Here we have on the back, got isolation tracking so that, you don't short out against like the heat sinks right here. And we got cross, overland connections, as I call them, over here. It's ready to go. We are pretty much go for final assembly. Now, on one of these screw holes, I have a little band right there, which I actually soldered to the heatsink, which, as you know, is connected to these guys. And these guys, their tabs are grounded. That's going to be where our ground connects to the chassis. You know, you have that somewhere, at least once. These guys have heatsink goo on them. So, you know, I forget to put in something resembling a fuse. So, hopefully that's not a problem. I just want to take this one screw out here so I can clean that spot so we can get a ground bond. So for that one screw terminal right there, file on this just to get the paint off of it, rough it up a bit. That should be good like that. Old toothbrushes for the sweeping. Now I feel like this guy could be put just a little bit straighter or not. No, that's it. I got pencil marks under here that I don't care for. Just kind of erase that. Let's get our hardware final into place. One last wiggle. Okay, need to get in there with a grip. Okay, so we just want to do, seat that in there. Hovers off a bit of a cantilever, but that should be fine. Get one of our kep nuts. It's gonna be tricky tightening that up into that odd location. Looks like I'm gonna have to fish it in with this thing and kind of poke at it with a screwdriver. Oh, that's what we're resorting to. Tightening up this nut. I might be able to get my tool in there. Key term might. Is that the right size? No, I can't get it around the heatsink. Okay, good old twist it with pliers. I'm not sure how tight I managed to get that. This is the right size for the kep nut, but it's not happening, you know? All right, that's gonna have to do. Now, I'm guessing I should solder those in before I put the other kep nut into place. So, don't know how well you're gonna be able to see this. My vision takes priority. I'll wrap just loosely around there, just so that they're gonna make a good solid contact. Kind of pinch them on there. You know, it's like we might be able to get it off after if we have to change that. No promises. Just now we have to solder it. Yeah, that should be making a connection now. All right, let's get the final kep nut in there. Is there any tool I can get in here? Well, a slight tolerance clearance issue here. Maybe I should move those back one. But I want to get a good, you know, leverage point. Because like this guy, it's floating here, but it's solid, you know? That's as good as it's getting, I think. Nothing's touching anything bad. Haha. A little bit of cable management might be in order. Like I think I want to loosen this guy, rotate it 180, then tighten her back up. And this guy will be more down oriented. Got these control wires, little haywire. I think they'll be fine. This control line goes onto there. This power line, which I cut very short, but it reaches like that. I just have to make a hole for this, and there's a lot of room. So anywhere you want, bud, anywhere you want. Somewhat symmetrical and in line with this. So right there will do. I don't think this bit is straight. That's just something resembling a pilot hole. We need to bring in our cone head buddies here. Determine which one is the correct size. 9/16, or is it supposed to be 1/2 inch? It could start at 1/2 inch. So let us see. We'll get in a hole through there. Hi! A little bit of jamsky there. Hey, don't frick around, bud. Okay, after all that trouble, let's see if 1/2 inch is it or we gotta go deeper. Yeah, 1/2 inch is good. All right. I got chips everywhere this time. All right, now I gotta clean this mess. Yeah, once again, the crotch full of bumble dust. Make sure there's none hiding in here. Okay, this is exciting. This is a project that I've been working on for months. Come on now. Ho, ho, ho. I don't know, would this thing even be considered digital? I don't think it would. I think this is completely analog. Power output there. Power input hiding up here. Are you ready for this? No smoke. Turn it up. Oh, the capacitor. With that capacitor on the output section, when you turn down the volume here, it takes time for the recovery. All right, well, here's something resembling a small 12 volt light bulb. Should be able to loosen on these terminals now. They have nice little screw clamps. Oh, that's our fresh crack. That should be connected now, kind of. Oh yeah. PWM, PWM, PWM. Oh, don't look right at it, bud. Press the button. Rejects phasing. Then that's supposed to be opposing. Hey. Yeah, there we go. That should be on the opposing phase right now. It's trying to change directions, but light bulbs don't recognize phasing changes now, do they? All right. The meter. What does the meter have to say? All right, meter. We're at negative 13.44. Press the button. Bring it down, and now we're at positive 13.44. Bring it down negative. Bring it down positive. Oh, yeah, bud. It is outputting what it's supposed to be outputting. Let's fire up the electrovision here and see what it has to say about our voltage ripple. Probably still dirty as frig. Can I even clamp this on here? This is just getting haywire. Ugh. I don't want to fire up a whole second camera here, so let's get an alternative angle. All right, let's bring up the voltage till it shows up on the map. Oh, I'm using the red probe. I'm not supposed to be using the red probe. I have channel 1 calibrated for this application. I'll just switch them over. Let's bring up the voltage. Eventually, at some point, it's gonna... 500 millivolts of ripple. Let us, and Tomato, bring this down. I want to see higher resolution what's going on here. Let's bring it up. How high can we get it in the 200 millivolt scale? We can get to 9 volts. Okay, so we'll bring it up and eventually it's going to hit the threshold on the screen. There it is. Oh, look at that. Look at that rippy right there. Oh yeah, bud. That's ugly. I wish I could do better than that. And I have in other designs, but just not this one. We could do better. So let's stop, pause that thing. So our ripple, those are extreme peak to peak, but if we go and tune in on it a bit, let's say we didn't have those peaks, and we'll go down to just, the more aggressive section here. Well, that's just over 200 millivolts. Just over 200 millivolts. So that's okay. Wow, for running some silly motors on a little thing, I think it's gonna be fine with that. It's not high-tech electronics that we're running here, so I don't think we could get a frequency reading on that. Frequency not found. It can't see the duty cycle through the inductor. But if I go back to channel 2 here, where I'm set up for it, and I probe around inside, I'm gonna have to grab some negative. Here, let's grab from the heatsink. And then we will probe on the PWM is right here. Ooh, this does not look promising. No, that's not the PWM, that's the clock signal, bud. No wonder I'm getting a hokey reading. PWM is here. Ah, there we go. Duty cycle, 50%. And then you can see that wobble bob. That's because the voltage feedback's limiting it. Won't let it get any more than that duty cycle. And all the way down, and that's our minimum. Clear messages. Come on. Frequency duty cycle. Wah. 220 kilohertz. 230. 245. Oh boy, we got more boost out of this pupper than we were bargaining for. That's okay though, that's okay. Little bit of a curvature there. If we go over here, output of the MOSFET. Yeah, you see those big spikes there? I found tricks to filter out those spikes. They involve adding capacitance right onto the MOSFET. Oh, yeah, see, the voltage feedback has a funny effect there. But yeah, it's working as intended, so that means there's one last thing to do. Put the covers on it, and then put a train on it. Fresh. Oh, look at this. Fresh. These screws haven't even been opened. Hell, I'm gonna have to there's no threading in there even. We're gonna have to force those in there. Oh boy, why would they do it like this? That's okay, I have an app for that. Dum 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 dum. Dum 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 dum. And 2 more times. Okay, that's gonna be nice now. Oh, except we got some deburring to do again already. Just want to make sure no junk falls in there. All right, let's try that again. Oh, yeah, going smooth now, bud. And then finally, it came with some nice rubber feet. A little bit of surface prep. Where do I want to put these? Narrow or wide? That's a full featured enclosure. It even comes with feet. Oh, how fancy. I guess that's why it's worth $40 plus tax. Now, if only I could get those feet on straight. There it is. Oi, no. Oh, you little teaser. There's one last step. The knob. Now there it is. Okay, these sides are a bit but it'll be fine. Now, we have button, we have lights, we have flashy blinky, we have knobby. Now I gotta hook up the train. Ordered off eBay. This is the track system I ended up with. Power model. Made in Italy. It was HO track set. It was just a complete circle. I got it for pretty cheap. Power gets connected to this general piece right here by just putting wires through these holes. Oh, we gotta go encircle this thing. Make sure they're all tight. So the only thing left to do now is connect on this. I'm hoping I have cooperative phases here. My intention was for it to match up the positioning of the tracks. So I'd want this to be the blue or the first one. And you don't even have to wrap it around. This terminal strip, it's made by Curtis Terminal Strip 2. There's a whole part number. It's the same one that I used in my bell ringers. If you want to know what it is, go watch the bell dinger video and just change one of the numbers from an 8 to a 2. And you got this thing. All right. And I don't even know what direction it's supposed to go in, but new for 2020, the PPC TTC PWM solid state controller. Oh. Yeah. That's full tilt right there. At some point it's gonna derail because, you know, it's silly like that. What's even the point of reverse? Where are we gonna go? We're gonna back up just like... Oh, the action on this is actually really nice. That knob, you just sweep it with the finger and then, you know, back and forth, and back and forth, and back and forth. And goodbye. That's pretty much all there is to it. How slow can you go? Oh. It's not getting stuck. Oh, now it got stuck. Creeping along. Zoom, 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 zoom. Oh, okay, we're just gonna stop at the station here. Ding, 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 ding. Pay your fare. Sorry, we don't take change anymore. It's, Presto. We only take Presto now, bud. Okay, you ready? Oh, wait, sorry, wrong way. Let's go. Oh, traffic. Oh, we got to keep stopping. This is how a TTC in Toronto actually is. Oh, wait. Oh, wait, here. Okay, hold on. Oh, yeah. Yeah. Oh, yeah. Oh, wait. No. That is, oh, yeah, it's traffic in Toronto, but, oh, wow. Oh. It even has the light in it. I'm getting misfires. It's almost like it worked better in prototyping. It's good enough, though. That is just such a slick action. Like, come on, guys. You gotta admit, that's freaking cool. You know? You got it, and you can change the gear, and then just whoop. Basic logic. Not even digital, just completely analog. No ones and zeros, just voltage potential. Priority voltage potential. Different levels of resistors. It's just one signal overcomes another. Whatever has priority. And then we can do this kind of thing. Everything lines up, everything works, it's overrated. We could hook a motor much bigger to this. I don't have any loads quite the right size. But after all this time and effort, this is gonna be fun for about 15 minutes, maybe a half an hour, maybe an hour, and then it's just, okay, put it away and forget about it. Which is why I overbuilt this so I could use it for other things. But hey, it's done now. It is done. Done dealy. So, I hope you enjoyed this. Hopefully there's some train aficionados who, even though this, probably think this is pretty freaking silly because the model train tech is way advanced past this now. They got hardcore digital stuff from what I've seen. I don't know that much about it, but hopefully if any train guys are watching, you get a kick out of this. Like, you gotta get a bit of a kick out of this. Not necessarily the best design. Do I recommend it for your kit? I don't know. How much is it worth? I'm surprised it hasn't derailed yet. When I was testing it with the prototype, oh boy. Yeah. Stay tuned. I like to build circuits sometimes. Not exactly sure what I'm doing next, but there's gotta be something. You know it.